Hi friends, welcome back to my channel on statistics. If you are seeing my videos first time, then do subscribe. Let's go to the topic. In this tutorial, I am going to explain brief introduction about other statistics. In the before video, I will give you brief introduction about non-parametric inference. For the what are the some basics of non-parametric inference means. First, we need strong skills in probability distribution. After that, we need strong skills in order statistics and tolerance limits, empirical distribution, all things. Also, first we can see what is the order statistics. All things also see. This is the introduction about order statistics. Let x1, x2, and so on xn denotes a random sample from a population with a continuous CDF f of x. See, order statistics deal with why continuous CDF. Okay, here order statistics always coming from continuous distributions, so that the probability is zero that any two or more of these random variables have equal magnitude. Okay, in this situation there exists an unique order arrangement with the sample. Suppose that x1 denotes the smallest of x1 of from this sample. Okay, here x2 denotes the second smallest element and xn denotes the largest. This is the general arrangement of order statistics. Here x1 is the smallest value, here x2 is the second smallest, here xn is the largest value. See, denote the original random sample after arrangement in increasing order of a magnitude, and these are collectively termed as the order statistics. Okay, of the random sample x1 and x1. Here see, here the rth smallest, 1 less than or equal to r less than or equal to n, xr is called the rth order statistics. Now we can see some properties of order statistics. Here xn is the here subscript. When we are denoting like this, x subscript 1, when I am writing in subscript in box in curly brackets, or generally we use brackets. Okay, this denotes the order statistics. Okay, it is the maximum value of the sample, xn is the minimum value of the sample. Then how you can get median means, for odd numbers you can just take the n plus 1 by 2. For even numbers you can take n by 2 and n by 2 plus 1. Okay, then you have, we all know that how to, here central tendency measure for the central tendency measure for the order statistics is mean. See how you can get mean. You can just take the average of x1 first order statistics and large order statistics, and the same way how to we can find dispersion means, this is the dispersion. You can just take the highest value minus lowest value, it will comes under the range. You can calculate variance also. In some experiments the sampling process cases after collecting the r of the observations. For example, in life testing electric light bulbs, one may start with group of n bulbs but stop taking observations after the rth bulb. Out of the information is available only on the first. Okay, this is the simple example related to the order statistics. Order statistics are used to study the outliers or extreme observations. For examples, when the so-called dirty data means non-parametric, they are not going, we are not, we don't any predefined information about the data distribution. All things also comes under the order statistics. We can discuss each and everything also. See, our study of order statistics in this chapter will be limited to their mathematical and statistical properties, including the joint and marginal. Here, after later on tutorials, I will give you introduction about how we can find marginal probability, how we can find joint probability for order statistics. All things also we can discuss. Then we are going to the quantile function. Next we can see how we can do quantile functions also. Okay, here give brief introduction about quantile function also. See, okay, from here onwards we can start with quantile functions. We can discuss it quantile functions here or see, we can see what will happen context. We have already discussed how to use the mean and variance of the moments described in the probability distribution means. We are know the expected value of x is the mean and variance of x means expected value of x square minus expected of this is the central moment is variance, and mean is the raw moment. In some situations we may more interested the percentiles of distributions like 15, like if you take the median, a quartile, then it will becomes under the quantile function. For example, if x represents the breaking strength of an item, we might want to know the median strength. The median is 50% quartile. Okay, or the strength of the survived by 60% of the items. the 40th percentile point. These all things comes under the quantile. See, a quantile of a distribution is the value of x such that a specific percentage of probability is at or below. The quantiles are divided area under the PDF into two parts. This is important point. Okay, here we all know that f of x, this is the general notation for f of x. Okay, when you are dealing with quantiles, our quantile value always lies between 0 to 1. Okay, this is the quantile notation, xp equal to f inverse of xp. Okay, then here one example also given. If we take the example of exponential distribution, here this is the CDF of exponential distribution. When x less than 0 we have 0, when x greater than or equal 0 we have 1 minus e power minus lambda x. Here lambda is 1 upon 2. Okay, this is a simple example related to the CDF. See how you can get quantiles means, here you get this is equal to the p, then you can just take the how you get this term means, you can multiply log on both sides and you can solve derivation, you can get this thing. Okay, minus 2 log of 1 minus p, because p is going this side, then 1 minus x going this side. When then you can apply log on both sides, log e going to the cancel, then finally you got what you got. Here minus 2x by p, then qx of p equal to the minus, here minus 2 going this side, minus 2 log of x. Okay, this is the general notation, or we can say that formula of quantile function. Q of x equal to f inverse of xp means inverse of CDF. This is equal to infimum. We can take the infimum value of this function. Okay, this is the graphical representation of CDF. This is CDF. Okay, see our CDF start from 0 and it end with 1. Okay, now we can see how we can plot PDF means, this is the inverse of CDF. So we like this, our CDF will be like this and our percentile graph is like this. Okay, quite opposite to the percentile. Okay, how we can find expected values and variance of x for quantile function means, we all know that for expected value of x, just you can take the quantile function, then you can take with degree. For this is total continuous distribution, so we are dealing with integral symbol. These all are some results. We can discuss these results with proofs also. Okay, after these results we can discuss empirical distribution in the next video. Thank you for watching.